Okay guys, welcome back. We're going to try another one, a little quicker this time, a little less jabbering, okay? This is Unit 4, Handout 5A. It's question number 2. We have an open delta transformer. Looks like it says E-phase secondary is 480 volts. It's got a Y-connected load, and that's fine. Doesn't say anything about the ratio, and it doesn't say anything about the primary, and that's okay. We don't care. We can answer all these questions without knowing anything about the primary. So let's take a look at it real fast here and see what it says. What is the phase voltage at the load? We're going to take that voltage, from phase to line to phase, okay guys? And E phase secondary is 480, and since E phase is equal to a line, E line secondary, guys, is also going to be 480, okay? Now that's from here to here. What it's asking about is the phase voltage at the load, so it's asking about E phase load, okay? And since it's Y, that 480 volts is going to get split over 2, and so it's going to be 480 divided by root 3, okay? And that's just because it's a Y-connected load. So 480 divided by root 3. 277 point, 1 volts, okay? So that's the answer to that, 277.1 volts. Now, why did we have to calculate that? Because of this one. Calculate the line current to the load for the circuit above. So that I phase load, guys, is right there, right? And we're going to calculate it using Ohm's law, okay, guys? So it's going to be the voltage dropping across that divided by 34, right? So I phase load is going to be 277.1 divided by 34. Nothing to do with open delta. We're just dealing with that Y-connected load there. We figured out the voltage across it. Now we're going to figure out the current through it. 277.1 divided by 34. 814.7. That's wrong. Totally wrong. Okay? Try that again. I'm an idiot, basically. 8.15. Okay? 8.15 amps. I'm going to switch markers because that's nice. All right? So, and that's the phase current, right, guys? So the line current is also going to be that I line secondary, because it's Y, right? 8.15 amps. So even though we figured it out for I phase load, I line secondary is also going to be 8.15 amps. Okay, guys? Because we always got to figure out the phase current before we figure out the line current, right? What is the phase current in the secondary winding of the open delta transformer? Well, I've got a line current of 8.15, must also be that. So this is going to just be 8.15 amps, and that would be measured right here. I phase secondary, 8.15 amps, okay? Calculate the kVA of the open delta transformer. So we've already decided that the VA was equal to E phase times I phase times 2, okay guys? And the phase voltage is 480. Phase current is 8. And multiply it by 2 because there are 2. So it's 480 times 8.15 times 2. 7824. Okay, guys? Calculate the kVA of each of the two transformers that make up the open delta transformer. Well, if this is the VA for both of them right there, then one of them is going to be half of that. So, I have two choices. I can go 480 times 8.15, or I can just divide that by 2, and it's not going to make any difference. So we'll go 480 times 8.15. Okay, 3912. And you can see that that's exactly half of that. Okay, guys? So they would be 3912 each if you were making this up out of two single phase transformers. Calculate the kVA of the three-phase closed delta transformer to feed the same load. Anytime I ask you to calculate the kVA of a closed delta transformer, the easiest thing is to just calculate the VA of the load, okay, because they'll be the same. So the VA will be E line 480 times I line 8.15 times root 3. Okay, guys, and that would be the VA feeding the load, and that would be the VA of the closed delta transformer. 480 times 8.15 times root 3. It's just E line, I line, root 3. Always works. 6776 VA. All right, guys. Calculate the kVA of each of the three transformers that make up the closed delta system. It would be, I have two choices. It would be, the best way to do it is just divide this by 3, guys. It's going to be 6776 divided by 3. All right, guys. You could do it, you'd have to figure out the phase voltage if it was closed delta and all that. I'm not doing that, okay? So it'll always be, that divided by 3. 6776 divided by 3. So these are 2259 VA each. Okay, guys? And this is each too. This one. Okay, and the reason I'm getting you to calculate these two, okay, because you'd have to order 3 of these, or you could order 2 of those. 2 of those if it's open delta, 3 of those if it's closed delta. Buy whichever one is cheaper. All right, guys? So, your homework. Terrible. All right, guys? There is a handout here. 3-phase open delta practice. It is Unit 4, handout 5. I think it's B, okay? And it's got a whole bunch of questions there, open delta questions to try. All right, guys? And there's extra practice, Unit 4, handout 5C, okay, if you want to try some more open delta questions, okay, guys? Then there's a handout, Unit 4, handout 6, okay, guys, and that's on instrument transformers, and by the way, that is there for your information, but it will not be on the test, so have a look at that one if you want to. And then you'll notice that the next one is the test review, and you should you're going to have to do that one before the test, which is coming up, okay? Because there's no more lessons after open delta, between open delta and the test. All right, guys? So just have a look at Econestoga to see what you're supposed to do.